Okay, so let's start with the second tutorial on AWS Data Pipeline. So now in this tutorial, let us now try to understand AWS Data Pipeline architecture. That is, what is the architecture in which it works. So AWS Data Pipeline is a web service that is used to automate the movement and transformation of data. With AWS Data Pipeline, you can define data-driven workflows so that tasks can be dependent on the successful completion of previous tasks. A data pipeline is a series of processing steps to prepare enterprise data for analysis. Organizations have a large volume of data from various sources like applications, Internet of Things, that is IoT, devices, and other digital channels. However, raw data is useless. It must be moved, sorted, filtered, reformatted, and analyzed. For business intelligence, a data pipeline includes various technologies to verify, summarize, and find patterns in data to inform business decisions. Well-organized data pipelines support various big data projects such as data visualization, exploratory data analysis, and machine learning tasks. So we have seen that AWS Data Pipeline is a web service that can be used to automate the movement and transformation of data, which is necessary to keep the movement of data under control. With AWS Data Pipeline, one can define data-driven workflows so that tasks can be dependent on the successful completion of previous tasks. It is important for the data transformation, and AWS Data Pipeline enforces to the logic that you have used up. The following components of AWS Data Pipeline work together to manage your data. A pipeline definition specifies the business logic of your data management. A pipeline schedules and runs tasks by creating Amazon EC2. EC2 is nothing but the Amazon EC2 is a cloud computing platform that can be auto-scaled to meet the demand. Instances to perform the defined work activities. You upload your pipeline definition to the pipeline, then activate the pipeline. You can edit the pipeline definition for a running pipeline and activate the pipeline again for it to take effect. You can deactivate the pipeline, modify a data source, and then activate the pipeline again. When you are finished with the pipeline, you can delete it. Task runner polls for tasks and then performs these tasks. For example, task runner could copy log files to Amazon S3 and launch Amazon EMR clusters. Task runner is installed and runs automatically on resources created by your pipeline definitions. You can write a custom task runner application, or you can run the task runner application that is provided by AWS Data Pipeline. For example, you can use AWS Data Pipeline to achieve your web server's logs to Amazon Simple Storage Service, that is S3, Amazon S3, each day, and then run a weekly Amazon EMR cluster over these logs to generate traffic reports. AWS Data Pipeline schedules the daily tasks to copy data and the weekly tasks to launch the Amazon EMR cluster. AWS Data Pipeline also ensures that Amazon EMR waits for the final day's data to be uploaded to Amazon S3 before it begins its analysis. Even if there is an unforeseen delay in uploading the logs, that is S3 is nothing but the Amazon Simple Storage Service, that is also known, in short it is known as Amazon S3, is an object storage service that offers industry leading scalability, data availability, security, and performance. Accessibility AWS Data Pipeline. You can create, access, and manage your pipelines using any of the following interfaces. AWS Management Console provides web interface that you can use to access AWS Data Pipeline. AWS Command Line Interface, that is AWS CLI, provides commands for a broad set of AWS service, including AWS Data Pipeline, and is supported on Windows, Mac OS, and Linux. For more information about installing the AWS CLI, see the corresponding document for that, or the AWS Command Line Interface. AWS SDKs provides language-specific APIs and takes care of many of the connection details such as calculating signatures, handling request retries, and error handling. Query API provides low-level APIs that you can call using HTTPS requests. Using the query API is the most direct way to access AWS Data Pipeline, but it requires that your application handle low-level details such as generating the hash to sign the request and error handling. Before we dive into the AWS Data Pipeline, let's first understand the architecture. Let us look into another perspective. Data pipeline architecture is the process of designing how data is surfaced from its source system to the consumer layer. This frequently involves, in some order, extraction from source system, transformation where data is combined with other data and put into desired format, and loading into storage where it can be accessed. This is commonly abbreviated and referred to as ETL or ELT pipeline. Its importance to understand: most data pipelines aren't a linear movement of data from source A to target B, but rather consist of a series of highly complex and interdependent processes. For example, data may be extracted from multiple sources, reorganized, and joined at different times before ultimately being served to its final destination. Why is the data pipeline architecture important? For data engineers, good data pipeline architecture is critical to solving the 5 V's posted by big data, that is, volume, velocity, veracity, variety, and value. A well designed pipeline will meet use case requirements while being efficient from a maintenance and cost perspective. 5 Data pipeline architecture designs and their evolution. ETL, that is extract, transform, and load. The Hadoop era, roughly from 2011 to 2017, arguably ushered in big data processing capabilities to mainstream organizations. Data then and even today for some organizations was primarily hosted in on-premises databases with non-scalable storage. Despite Hadoop's parallel and distributed processing, compute was a limited resource as well. As a result, data engineers spend considerable time modeling data and optimizing queries to fit within these constraints. Data pipeline architecture typically consists of hard-coded pipelines that cleaned, normalized, and transformed the data prior to loading into database using an ETL pattern. Some organizations chose to still leverage an ETL pattern in the cloud, particularly for production pipelines where data contracts can help reduce downtime. The modern data stack era, roughly from 2017 onwards, saw the widespread adoption of cloud computing and modern data repositories that decoupled storage from compute, such as data warehouses, data lakes, and data lake houses. The term modern data stack refers to the multiple modular SaaS solutions that comprise the data platform and pipelines. With cost and physical compute storage limitations largely lifted, data engineers started to optimize data pipeline architecture for speed and agility. Data could now be extracted and loaded prior to being transformed for its ultimate use. This scale and flexibility of the cloud and an ELT design pattern unlocked additional valuable use cases such as more widespread analytics, experimentation, and machine learning applications. While these batch data pipelines were ideal for analytical use cases, there has been an increased need for real time data. Streaming data pipeline architecture are typically run in parallel to modern data stack pipelines and used mainly for data science or machine learning use cases. Apache Kafka is the most common tool, and if it comes in many flavors, Confluent Cloud, AWS, MSK, self hosted, etc. etc. The pattern can be described as stream, collect, process, store, and analyze. The most common architecture involves sending raw data directly to the application. But sometimes Flink, Apache Flink is an open source unified stream processing and batch processing framework is used as part of the transformation process. Another common pattern is to also land this data in a lake or lake house, eventually making its way to warehouse for analytical use cases. The direct source to application streaming data pipeline architecture can present challenges such as the inability to fully validate data quality or model the data. However, the value and benefits and near real time data are hard to deny. Data pipeline architecture are constantly being reinvented. Two emerging data pipeline architecture include zero ETL and data sharing. Zero ETL is a bit of a misnomer. These pipelines offer from traditional ELT pipelines by doing the data cleaning and normalizing prior to load. In many cases, the data stays in data lake and is queried from there versus moving from the data warehouse. At the moment, this tight integration is possible because most zero ETL architecture require both the transactional databases and data warehouse to be from the same cloud provider. Some examples include AWS Aurora to Redshift, GCP, that is Google Cloud Platform, Bigtable to BigQuery, and Snowflake of Unistore. This trend is competing with another data pipeline architecture undercurrent, where some organizations are considering decoupling their storage and compute at the vendor level with companies like Tabular. Thank you.